Just like to introduce myself. My name's Steve Smith. I'm with Swagelok Cambridge, the local Swagelok Service Center. We're based out of Billerica, Massachusetts, and I'm the sales director with Cambridge Valve and Fitting, or Swagelok Cambridge. Just to give you a little bit of an intro about Swagelok, Swagelok Company is based out of the Cleveland, Ohio area. We have approximately 25 facilities in the Cleveland area, and we do over $2 billion in sales worldwide. Swagelok employs over 5,000 associates globally. Approximately, we have 200 sales and service centers globally that employ about 3,500 distributor associates or sales and service associates. We train over 40,000 people annually worldwide. Cambridge Valve and Fitting, again, Swagelok Cambridge is the local sales and service center. We service Maine, New Hampshire, Massachusetts, and Rhode Island. 36 associates, we have 11 outside salesmen. Our website is cambridge.swagelok.com. One of the things I just wanted to, if anybody is interested in a catalog, we offer obviously online all of the information at swagelok.com or our website, but we also offer paper, USB, and CD catalogs of Swagelok products that are available. So anytime, just let us know and we'll take care of that. If there are any questions, please use the Q&A. Please do not use chat or under the More feature, chat feature. We'll stop and answer some questions partway through, and then we'll answer questions at the end. With that, let's get started. What we're going to talk about up front is tubing, tube identification, tube pressure ratings, tube supports, cutting and deburring. Then we're going to get into tube fittings themselves, the tube fitting components, the big three, SAT 12 hardening, fractional versus metric, and then we're going to finally finish with installation, ferrule orientation, installation procedures, remake procedures, then some safety considerations. And we've got a terrific video at the end that's going to highlight the extreme capabilities of the Swagelok tube fitting. With that, when we take a look at tubing, tubing is extremely important with the Swagelok tube fitting. Tubing is the component that we don't manufacture. We manufacture the four components that make up a Swagelok tube fitting. We manufacture the front ferrule, rear ferrule, the body, and the female nut that helps make the fitting work. But the fifth component, extremely important component, is the tubing itself. When you look at tubing, your tubing is predominantly stainless steel. I'll say over the years, we used to do a lot more in brass, but you see brass being used less and less. Predominantly, people have gone to stainless steel, I would say across the board in a lot of the applications that we deal with. And your typical stainless steel will always have a ley line on the surface of the tubing. It will identify the material. 316 stainless typically is what we see. It will tell you the outside diameter, in this case, 1/4 inch. It'll give you the wall thickness too, and typically the specification. In this case, it's ASTM A269. One of the things that we recommended is under tube specs is you utilize seamless tubing or welded and drawn. I apologize, that's a typo. Welded tubing itself has a seam that goes across the outside surface. It's actually rolled out and then welded together. You will have probably, I've only dealt with it a couple of times over the years, and it's a high probability you'll have a leak. So you want welded and drawn. One of the issues with stainless tubing is that you want your tubing not to be harder than the tube fitting. The situation is that you always want the tube material to be softer than the fitting. So on stainless steel tubing, we recommend Rockwell B 90 hardness or less. Wall thicknesses for each size of the Swagelok tube fitting, we have recommended min and max wall thicknesses, which we'll get into. There are allowable pressure ratings and then applicable D ratings. That applicable D ratings can be basically deemed with higher temperature. When you get into higher temp, we derate the pressure rating on the tubing. So you have to be careful depending upon what your application calls out in terms of temp and pressure. One of the things, and I'll read it off, this is just a graph that comes from our tubing data. A typical suggested ordering information for Swagelok stainless steel tubing that's recommended, and it's recommended for all tube fittings. For stainless steel, high quality, fully annealed, type 304, 304/304L, 316/316L, 317, 317L, or 321 or 347. seamless or welded and drawn. Stainless steel hydraulic tubing, ASTM A269 or A213 or equivalent. Hardness not to exceed 90 on the Rockwell B. Tubing to be free of scratches, suitable for bending and flaring. OD tolerances not to exceed plus or minus 5/1000ths of an inch up to 1 inch OD tubing. Now, one of the things that we offer here is we have a graph we're showing tube OD from 16th up to 2 inch. Swagelok tube fittings are available in all of these fractional sizes as well as a full line of metric sizes. So what I'm going to do, I'm just going to take half inch stainless steel. And we take a look, we can use 035, 049, 065, or 083. These are the recommended wall thicknesses. Could you use an 028? You could. Would you get a good seal? We're not terribly sure. It would depend upon the application. The reason for the minimum wall thickness is that we need enough resistance to the swaging action of the fitting to potentially coin out any imperfections on the tube surface. If you go to too thin a wall, you may not get that action and it could be a potential leak point. Conversely, on the other side, we max out at 083. Could I go up to an 095 or even a 109? You could, but what's going to happen then is you're going to have a wall thickness that is so heavy that it's going to be similar to having very hard tubing. Again, we recommend on stainless, don't exceed Rockwell B90. If you go higher than that, what happens is the tubing is so hard, and then when you make the Swagelok tube fitting up, the design of the Swagelok tube fitting is that it's going to swage the tubing or deform the tubing. We don't cut into the tubing, bite into it whatsoever. We deform it. It's a mechanical type fitting. If in fact you have too hard a tubing or too thick a wall thickness, what will happen is you won't deform the tubing. You'll actually deform the ferrules onto the surface of the tubing and you'll end up with a frictional fit. So you think you're going to even a better pressure containment scenario going above 083 when in fact you could be getting into a situation where if you had extremely high pressure, you could experience a blowout. So you want to stay within the recommended pressure ranges. These are the working pressures. So you can use half-inch Swagelok tube fittings up to 6,700 pounds. Now, depending upon if there's female end connections on the fitting, that could be derated. Also, if you get higher temperature, that rating can also be derated. But the key is we can do that. Now, these are based on a 4-to-1 safety factor. So 4 times 67 is where that the fitting will hold to. Our specification is that we'll hold the fitting to the burst point of the tubing without leakage. I go on. We look at this. We've got tubing on the left. We've got pipe on the right. Tubing, better strength to weight ratio. Tubing is lighter. Typically, you can utilize a smaller size of tubing for the fact that you'll get better flow characteristics. You use the full wall thickness of the tubing to contain the pressure. When you get into piping, you're going to either weld or thread pipe. If you're going to thread pipe, you have to cut a thread. So you're going to have to actually utilize extra wall thickness, which is heavier. And typically when you purchase pipe, you're purchasing it such that you're paying by weight. So it can cost you a little bit more. So typically you can go to a smaller size with the tubing. One of the other aspects is with tubing versus pipe. Generally, again, you can downsize. Look at fewer connections are required. A simple U shape. You need 2 pipe elbows and you have to cut and thread and put Teflon tape on 4 connections. With a piece of tubing, you can simply bend it. One of the issues with pipe elbows, it has 3 times the pressure drop across it than a sweep 90 on a bent piece of tubing, Tubing has a better surface finish, so there's less frictional drag on the ID of the tubing, so you get better flow characteristics also. So typically you can downsize a tubing system to get the same flow characteristics and eliminate a lot of potential leak points, and it'll be a lot easier to maintain in your system. Tube handling, extremely important. As I mentioned, we're going to seal with the tube fitting on the surface of that tubing. We don't cut a thread. We're not going to weld it. We're going to seal right on that surface. So you want to make sure that you have a good workmanlike surface. Don't drag it off racks. Don't drop it. Don't drag it across the floor. Handle it gingerly. Treat it well. And I call it the rule of thumb. If you see any small scratches, nicks, etc., if you can pick it up with your thumbnail, then maybe take a piece of emery cloth or a suitable product and see if you can just dress it out. If you can't, don't insert that into a tube fitting and make your connection there. There's a probability, depending on your application, thin gas, helium, hydrogen, or you're going vacuum, you could potentially have a leak path. So again, surface finish is very important. Here's a couple examples. On the left, we've just got some scratches on the outside diameter of the tubing. And then on the right, we've got some dents and whatnot. Again, we want to take care of our tubing. We're sealing on the outside surface, so we want to make sure that we had a good, smooth, workmanlike surface. This is just showing when you do a tubing installation, you always want to do your installation such that you can stagger, etc., and you can get good accessibility to your fittings. Every Swagelok tube fitting is a point of access into your system. You can simply just take it apart and then reassemble it when necessary. So you always want good accessibility for your fittings. Here's again just showing multiple tubing supports. We've got various sizes. Looks like we have quarter, 3/8, half, and maybe some 3/4. But you'll notice that we have our tube supports in well. We want to support our tubing, maybe put expansion loops in. You look at some of the nitrogen line at the top, it's at 6,000 PSI. You want good tube practice. One of the things that we offer, we have a tube fitter's manual. Small book, it's got a wealth of information. One of the scenarios in there, it talks about tubing supports, depending upon the size, how far apart your support should be, along with a wealth of other information. If anybody would like one of these tube fitters manuals, just let us know. Go on our website or send us an email and we'll get one out to you. Tube cutting, important. How are you going to cut your tubing? Generally one of two ways. You're going to use a tube cutter or you're going to use a hacksaw. Or maybe a power saw. With a tube cutter, you basically just want to position your tubing between the wheel and the rollers. And you just tighten down on the handle until the wheel makes contact with the tubing. Make a couple of revolutions. Always go in the same direction. When it gets loose, just advance the handle a 1/16 of a turn and continue that. And continue that methodology all the way through till the tubing is cut. And it's not actually cut. You're actually separating the metal when you do a tube cutter. If you're going to use a hacksaw, this just depicts a tube saw guide, which can make life a little bit easier. You can put it inside of a vise, then you take your hacksaw. If using a hacksaw, we recommend 32 teeth per inch at the minimum. That way you'll get a much smoother cut. But when using a hacksaw, you're going to end up with burrs on the ID and the OD, and you're going to have pieces that got inside of your tubing, which we'll show you momentarily. So here's some tube end preparation. If we look at the bottom left, that's what happens when you do a tube cutter. With a tube cutter, it's a continuous burr all the way around. Again, we're not cutting, we're separating the metal with a tube cutter. So you're left with a large burr, 360, right around the ID of the tubing. This in itself generally will never disengage, and you probably won't cause any contamination or anything, but what it will do, it may give you flow restrictions. If you have a number of these that aren't addressed, you could truly have some interesting flow restrictions in your system. So what you want to do is make sure that you deburr your tubing suitably on the ID and just slightly hit it on the outside. Now hacksaws, if you take a look, we've got burrs on the outside, we've got burrs on the inside, and we've got chips on the ID of the tubing. You want to make sure that you take the burrs off the outside. Burrs on the outside of your tubing, when you go to insert them into a Swagelok tube fitting, what will happen is they could cause scratches down the inside of the fitting. Again, depending on your application, a viscous fluid, not a problem. But thin gas, hydrogen, helium, vacuum, you could have a potential leak point. On the ID, the burrs left inside there, what could happen? They could become, they could break off, they could go downstream, they could embed themselves into a stem tip, they could get into a regulator, prevent the proper operation of a regulator, get into a mass flow controller, or just cause contamination to your system. You just want to make sure that you clean it up. Then also, when you see the burrs on the inside, you want to use a suitable rag, cloth, lint-free to take those out or blow it out with nitrogen, etc. But you want to make sure you have clean ends before you install it in your tube fitting. Deburring, important. Just use a good tool. On the left, we're just showing a deburrer. Right now, we're going to do the ID. You flip it around, and you can do the OD. You want tool steel blades. You insert it into the tubing, and you turn it in one one direction. Don't go back and forth. Just turn it one direction, 3 to 4 turns, and you'll take off the burrs on the ID. Or up in here, you got a hand tool, similar device. It's kind of like a knife, and you can just scrape the burrs off going in the same direction also. And then we go to the the OD. That was the ID. The OD, again, we flip around your deburrer, you insert your tube, again, go in the same direction, take it off. Also on OD burrs, you can deburr your tubing with a file. Not a bad way to do it also. Additional tubing considerations. Metal tubing material should be softer than the fitting material. We talked about that. The design of the fitting is that the Swagelok, the swage term means to move metal. We deform the tubing. And we don't on stainless steel with brass fittings. Again, brass ferrules, they're gonna friction fit on the tubing. They're not gonna deform the stainless steel tubing. So we generally like to keep same materials also. As you can see, the second point, mixed materials between tube fitting tubing may cause galvanic corrosion. Again, dissimilar metals could create galvanic corrosion, could take a very short time depending upon your application, or it could take forever and you'll never see galvanic corrosion. But the ideal situation is to keep stainless with stainless, carbon steel with carbon steel, copper tube with brass fittings. When you go to plastic tubing, throw it all out. You can use any material, metal material with any type of plastic tubing, and you're not going to have any issues other than pay attention to the aspect of your pressures. And if you've got a very soft tubing, as we're going to get to that in a moment, you want to use an insert. And then again, mixed tube fittings and tubing materials may be affected by different temperature changes. Each material has its own coefficient of expansion. So again, two different metals, you get into extreme temperatures, whether it be high heat or extreme cold, you could have leakage occur. Extremely soft or pliable Tygon tubing, tubing that you can depress with your fingers. You can squeeze it together. It's a wise idea to use an insert. That provides enough hoop strength and strength of the tubing when you insert it into the fitting that you'll get a swage, it'll hold, and the tubing won't blow out. It doesn't seem like a big thing, but I've seen 70 PSI plastic lines just flipping around. It could cause some damage or it could cause an injury, so be careful. The last point, which is very important, is when you bend tubing, or even when you don't bend tubing, if you use a straight line, there's a minimum insertion depth required to fit into a Swagelok tube fitting. When you look down the bore of a tube fitting, there's a machine shoulder inside the fitting. Your tubing always has to bottom against that or you won't get a proper fit up. That enables the ferrules to do their swaging action. So you want to make sure, especially when bending, that you've got a certain amount of straight length that you can bottom the fitting right inside there. So now we've got tube fitting components. We're going to talk about tube fitting objectives. SAT-12 hardening, which is our patented case carburization process, the big three that's important to when you look at tube fittings, and then fractional versus metric. All right, when we take a look at a Swagelok tube fitting, we take one apart. This is what it consists of. What you're going to see is you're going to see the nut, the rear ferrule, and the front ferrule, and the body. The primary function of two ferrules, this is the heart of a Swagelok tube fitting. The front ferrule's primary function is to seal. The back ferrule or rear ferrule's primary function is to grip and hold the tubing and prevent blowout. The nut and the threads on the body, located right here, are strictly for engagement. They enable you to make the front and rear ferrule do their swaging action on your tubing. Inside of all of our Swagelok female nuts, we silver plate on stainless steel. What it does is it prevents any galling, gives you a long life on the nut, and you can get many, many remakes. When you look into the body, you'll see a machined bevel right here. Your front ferrule fits right into that machined body or bevel right there. So it acts as a seal. So this area inside of the mouth of the fitting and the outside of the front ferrule, that's your primary seal area. We go down inside and we'll have a cutaway of that soon. There's a stepped shoulder or machine shoulder. When you insert your tubing, goes through the nut, the rear ferrule, front ferrule, and seats against that shoulder for proper orientation. Now, some of the important aspects of Swagelok tube fitting is the recipe that you make out of your stainless steel, your material certification. Two of the most important ingredients in a stainless steel material cert is chrome and nickel. The ASTM ranges on chrome is 16 to 18%. The Swagelok Min is 17% or higher. On nickel, it's 10 to 14%, and the Swagelok Min is 12%. Now, years ago, it was difficult to control, but today you can really control the elements that are going into your material. So what happens today, and I challenge anyone, pull other manufacturers' material certs and look at their chrome and nickel. They'll probably be hovering around 16 and 10 because you can do that and it will cost you less money. Swagelok goes mid-range and higher. And if anybody would like a material cert, again, please just let us know. What can happen with a low-grade stainless steel? Now this is a little bit of a stretch here, but this does happen and we've seen it. You get corrosion, you get poor performance, and it degrades over time. So it's important. Nickel, again, showing our range, our Swagelok minimum. Nickel effectively stabilizes the austenitic structure. And it basically provides a ductile, non-brittle alloy over a wide range of temp and media. Now we look at the chromium. Chromium provides corrosion resistance. That's what we're all looking for in stainless steel. It forms a passive oxide surface layer that makes steel stainless. The molybdenum adds corrosion resistance in certain chlorine media. Both help avoid strain-induced martensite. Now, we've got design differences. We've got 3 different styles of fittings here. We're showing you a single ferrule bite type fitting. How this fitting effectively works, here's your female nut, here's your body, here's the body bevel on the mouth of the fitting. When you tighten down on the nut, you're causing the ferrule to bow and you're biting into the tubing. You know, you've got a sharp edge, you bow the ferrule and it bites into the tubing. It'll give you a decent seal. Problem is over time, especially if you have vibration, maybe you've got a connector up against a pump, there's constant vibration, you're weakening the tubing and over time you could potentially snap that tubing. We go over to a twin ferrule bite type fitting. The twin ferrule bite type fitting, similar design. Both ferrules get bowed, both ferrules on the nose, they bite into or cut into your tubing. A little bit different with the Swagelok tube fitting. This is a mechanically attached fitting. We utilize a hinge and collet grip type fitting. We take a look here. Here's our female nut. Here's the body of the fitting. Here's the mouth of the fitting. This is our front ferrule. Again, front ferrule's primary function is to seal. We seal along this long line of seal here, and our secondary seal is right in here. We don't bite into or cut into the tubing at any point at this location. If any of you have made up a Swagelok tube fitting, and sadly enough, I can't do this through this webinar, but if you make one up, you disassemble it, you pull out the tubing with the ferrule swaged onto the tubing, you can grip the 2 ferrules and you can always rotate the tubing inside of the ferrules. We do not bite into or cut into the tubing. Again, our rear ferrule, it's a hinging, colleting, grip type fitting. So again, the rear ferrule's design is to grip and hold the tubing. We collet or hold the tubing on a very long line here. Again, we don't bite into or cut into it, but we grip and hold it to prevent blowout and make sure they get the max capabilities out of a tube fitting. One of the things that we can do with the Swagelok tube fitting is it's two ferrule design. It works on thin or thick wall tubing, and it compensates for thin or thick wall tubing. On the thinner wall tubing, you typically lower pressures. So what you're going to get, if you look at it, we're going to get more of a seal area. You're going to have more or less resistance of the tubing to the front ferrule. You notice the swaging that goes on here and the lack of swaging on the heavier wall ferrule or heavier wall tubing. So you're going to get less work with the rear ferrule, which grips and holds the tubing. But if you're going thin wall tubing, you're not getting into higher pressures. When you go to heavier wall tubing, typically you're going to heavier pressures, higher pressures. So you're going to get a little less seal on the front ferrule, but you're still going to get a seal that holds to our specification, but you're going to have the rear ferrule do more work. And it's going to do more work in grip and holding that tubing because you're going to be at much higher pressures. Now my next slide is called the Big Three. The Big Three is going to explain tube grip, gas seal, and vibration protection. The slide does it so well, it's an audio slide, I'm just going to play it. These are factors you need to consider when evaluating a tube fitting's performance.
The big 3 factors you need to consider when evaluating tube fitting performance are tube grip, gas seal, and vibration protection. A robust tube fitting design achieves maximized reliability in all 3 areas. Here's how Swagelok achieves high performance in all 3 areas and delivers you productivity and efficiency in your application. The Swagelok tube fitting hinging and colleting action provides more material of the back ferrule onto the tube adjacent to the tube grip. This extra material provides both direct axial support to the tube gripping function and colleting squeeze of the tube, unlike a bowing or bite type ferrule. This action provides a more robust tube grip over a wide range of installations and safely contains your fluid system without leakage, even at maximum working pressure. A gas seal is achieved by the burnishing or polishing that occurs between the front ferrule and the tube fitting body and the front ferrule and the tubing. This burnishing or polishing action accompanies concentrated zones of contact, as shown in yellow. This is a tube sample from the extreme rotary flex vibration test, demonstrating how the hinging and colleting action protects the stress riser. After high amplitude accelerated tube vibration, the sample fractured here, away from the would-be stress riser, by virtue of the colleting region provided by the hinging colleting back ferrule. By protecting the stress riser and supporting the tubing in the colleting region, fracture, if it occurs at all, occurs in an uncompromised section of the tubing. This means the life of the tubing was greatly extended.
Okay, what we have here is, again, this is a depiction, lower left, of finite element analysis. This shows a cutaway of the ferrules inside the tube fitting contacting the tube and a cross-sectional on the right view at the nose position of the back or rear ferrule that has gone through the carburization process. The diffusion of carbon has gone into the surface of the back ferrule and is not a layer applied on top of the ferrule. That white ribbon in the lower right is the consistent effect of carbon diffused into the surface, providing incredible hardness and corrosion resistance without dimensional change while retaining ductability of the material. And again, the Swagelok tube fitting is a patented tube fitting. A lot of people go around and say Swagelok's not patented, but the fact is we have active patents and it currently is patented in the rear ferrule between the surface process and also the geometry of it is still a patented design. And this particular slide is the two furnaces that provide the patented heat treating SAT process to the back or rear gripping ferrule of the fitting. And again, the hardness on our rear ferrule is compared to that of tooled steel, and it has the ductility to unhardened stainless. Again, patented process that we developed.
ASTM F1387 is a detailed test specification developed by the American Society for Testing Materials, or ASTM, for evaluating the performance of mechanically attached pipe and tube fittings, referred to as MAFs. The U.S. Navy adopted ASTM F1387 for military shipboard service in non-nuclear machinery space applications.
What this slide depicts, or that previous slide depicts, is that Swagelok, I believe, is one of the only mechanically attached fittings that's approved by the Navy on surface ships. So it's an important specification, we feel, and it's a testimony to the Swagelok's performance. Here we get into metrics versus fractional. If you have both fittings in-house, this is something you do want to pay attention to. If you're strictly only fractional, not an issue. If you take a look at a standard fractional tube fitting, whatever material or size it will be, you look at the female nut, you'll never see a step shoulder. And then you look at the body hex on the tube fitting, there'll be no step shoulder also. Great indication that it is a fractional fitting. If you take the fittings apart, the fittings will have, you probably need a magnifier to see, but it'll tell you, what size that the ferrule is. You go to a metric fitting. On all metric nuts and bodies, we put a machine step shoulder as an easy identifier how to determine if it's metric or not. So that's the key. You just want to make sure, do I have metric or not? And be careful of interchange if you carry both inside. So that's something you want to be careful of. So now we're going into installation objectives. We're going to talk about ferrule orientation, remake installation, and safety considerations. When you take a look at a tube fitting, if it's aligned properly, the ferrules are incorrect, what you're going to see is when you look inside of a tube fitting, here's the actual female nut. Here's the nut right here. Here's the female nut. Here's the rear ferrule. Here's the front ferrule. And here's the gap between the front ferrule and the body inside of the body bore of the fitting. So you'll see very thin lines. So that tells you a minimal gap between the mating surfaces, that it's aligned properly. That's if you just want to take a look down inside the fitting. We take a look at this depiction. This is a depiction, you see a very large gap right behind this nut. That's telling us that we're missing the back ferrule. Okay, you just want to make sure you want both ferrules in correct orientation. Go to the next slide. We've got a gap between the front and the rear ferrule. That's just indicating to us that the rear ferrule is put in backwards. Again, you want to see a smooth, thin line between here, here, and here. So you want to make sure that you get the orientation correctly for proper makeup. Now, manual installation of the tube fitting. So we're going to touch on 16th all the way up to 2-inch fittings and talk about them. The procedure up to 1 inch is similar, I'll say from 1/4 to 1 inch tube fittings. When we get down to 16th, 8th, 3/16, 2, 3, 4 millimeter, it's a slightly bit different. It's less of a makeup procedure. Then when we get over 1 inch tube fittings, it's a little bit different also. The defining factor with over 1 inch tube fittings, and we have tube fittings that go right up to 2 inch, is the fact that the outside diameter of the tubing over 1 inch has an allowable OD tolerance of plus or minus 10 thousandths. When we're dealing with 1 inch and under tubing to be used with tube fittings, that outside diameter tolerance is plus or minus 5. So what we do when we do a makeup procedure is here's a fitting, here it is, it's cut away. We take our tube. Again, we always want to cut the tube properly. Deburr IDOD, check the surface finish for a good surface finish, and then we want to insert it into the fitting. And here's that machine step shoulder that's down inside the bore of the fitting. So you want to make sure that you bottom it. When you do bottom it, we recommend that you finger tight the nut. Then we recommend that you make a scribe mark. Showing down here, you can start at 6 o'clock, or you could just make a scribe mark across the nut and the body hex as your reference point. We recommend an indelible marker or a metal scribe. And what it does is it gives you a reference point on your initial makeup to make sure that you've gone the proper amount of makeup. Another extremely important aspect is when you pull up a Swagelok tube fitting, you always support the body of the fitting and turn the nut. The reason being is sometimes when you're working with T's or crosses or maybe even an elbow, you've got a big body there. So maybe I just hold the nut and I turn the body. Well, when you turn the body, you turn this body, you're rotating the mouth of the fitting. And what happens is that's going to go against the front ferrule because the front ferrule isn't going to rotate. So you're going to score the sealing surface of the mouth of the fitting. So you always want to support the body of the fitting and turn the nut. Now, when we turn the nut, that doesn't impart any rotary motion on the rear ferrule. And the ferrules just drive straight in to deform the tubing and create a swage. So again, always support the body and turn your nut when you're making it up. So for 1/4 inch through 1 inch Swagelok tube fittings, you insert, finger tight, make a scribe mark, then you pull your fitting up a complete turn and 1/4. And then you'll have it to the holding point. We will hold to the burst point of the tubing without leakage. When you do tube fittings under 1/4 inch, 16th, 8th, 3/16, or 2, 3, 4 millimeters, it's a simple 3/4 of a turn. The reason being is you're going with smaller diameters, thinner wall thicknesses, you achieve the proper swage effect at 3/4 of a turn, and the fittings will hold to the burst point of those tube sizes as well. So for under 1/4 inch, it's 3/4 of a turn from finger tight. From 1/4 to 1 inch, it's 1 1/4 turns. Now, when we go over 1 inch, we go to our large fittings up to 2 inch. Again, you're dealing with a tubing that has a much larger OD tolerance. So we effectively preset the ferrules onto the tubing. We have hydraulic swaging units that preset the nuts and ferrules on automatically. Then you simply just go to the remake procedure on the fitting. Otherwise, if you decide to do it manually, you've got large wrenches and you have the capability to do it. Same procedure is you insert your tube, bottom into that large fitting. You finger tight your nut. You don't make a scribe mark yet because now what you want to do, you want to support the body. You're going to start turning the nut and at the same time, you're going to rotate the tubing. When you can't rotate the tubing anymore, you stop turning the nut. What you have done manually, if you have preset the ferrules onto the tubing, then you make your scribe mark on the nut and the body hex, or make it at the 6 o'clock position, and then you pull your fitting up a complete turn and a quarter. Again, you're dealing with different OD tube specification when you get above one, so you have to preset your ferrules. If we take a look at this, Swagelok tube fittings are one of the only gaugeable, commercially available tube fittings on the market. Now, some people say, is it a little bit gimmicky? It's not gimmicky. It enables you to verify that your tube fitting has been installed correctly on the initial makeup. Very important. I've been around a little bit, so I have seen and I talk with customers, they're OEMs, they send equipment overseas, all of a sudden they get a call, they've got some leaky fittings. So they end up sending a field tech in, whether that tech has to come from here or they've got a tech service overseas. Next thing you know, I would say 9 out of 10 times the fittings weren't pulled up enough. They snug the fittings, the leaks go away, and everything's good. It's a simple procedure to verify the makeup of your tube fitting. You do not use the gauge on remakes or after you make it up initially. It's strictly on your initial makeup. It's a simple no-go gauge. When you pull your tube fitting up correctly, you see if the gauge will fit in between the nut and the body hex. If it does not fit in, the tube fitting has been pulled up properly. Now, it won't tell you if you've over-tightened the fitting, but with stainless steel, the number one problem with leakers is typically under-tightening the fitting, especially if you get into a little heavier wall thicknesses on the larger sizes. It becomes somewhat difficult to pull it up, and the tendency is to under-tighten than over-tighten. If a fitting is under-tightened, you'll insert the gauge and you'll see that it'll fit in between the nut and the body hex. Fitting needs to be tightened up till that gauge does not go in. So again, it's a simple device. What enables us to be gaugeable? It's a simple factor. It's the ferrules. It's the machining tolerances that we hold on our tube fitting. The ferrules, a lot of other manufacturers stamp their ferrules from tubing. Tubing has allowable tolerances of 1 inch and under, plus or minus 5 thousandths. You get a 2 ferrule fitting, you get 2 ferrules stamped from tubing, you've got 10 thousandths on one, plus or minus 5, 10 thousandths on the other, plus or minus 5. You get a wide variance of a tolerance band. We machine our ferrules from bar stock and hold our tolerances within 1,000th of an inch. The end result is we have a very predictable dimension when you make it up. Therefore, we can create a gauge and make it up. It's a testimony to the tight tolerances and the materials that we utilize that we're a gaugeable tube fitting. Now, reassembly, very important. It's the same procedure for all sizes, whether it's the under 1/4 inch, the over 1 inch, or the 1/4 to 1, which is the bulk of what we sell. Prior to disassembling the fitting, first of all, make sure you depressurize your system. Always important. You don't want a surprise. Then we want you to make these marks. We want you to make a mark on the tube right here up against the nut. That will tell you when you go to reassemble and you go to finger tight that you've got the tubing and the ferrules set properly down into the mouth of the fitting, inside of the fitting. Then we want you to make a mark right across the nut and the body hex like this. What this does is when you take it apart, you know that when you go to retighten it, that when you get to here, that's exactly where your initial makeup was. So prior to disassembly, mark the tubing and the flats. Insert the tube end connection with the pre-saved swage ferrules into that body. Reinsert it. And then what we want you to do, when you reinsert it, take it with a wrench. Again, support the body as shown here, turn the nut. Turn the nut so that you get back to the original position, which is shown here, and then you tighten it slightly, about 1/8 of a turn beyond. That will enable you to, again, get to the position where the fitting won't come loose and it'll hold to the burst point of the tubing. And again, you do not use gap inspection gauges with reassembled fittings. Here is just an example of an over-tightened fitting. And you want to pay attention to this. If you over-tighten a fitting, there's a couple of checks for it. Now, initially, you'll get a good seal. You take it apart, and that's where the problem possibly could arise. One of the things that you'll notice here, at the end of the tubing, right here. Again, we swage the tube. The tubing ahead of the ferrules is slightly enlarged. This is an important feature because that fits into the ID of the fitting. This absorbs vibration away from where the seal takes place. But when you've over-tightened a fitting, if you make a fitting up correctly, this gap right here between the front ferrule and this rear ferrule, you can get your fingernail in between there. And you need that gap for retightening, because when we retighten, we're simply just moving the nut and pushing the rear ferrule forward 12.5 thousandths to expand that front ferrule out to seal against that body bevel. When you over tighten, what we've effectively done is we've driven the rear ferrule into the front ferrule. We've effectively welded it into a one-piece fitting. Then, if you look at the metal right here, we've lost the conical shape of the Swagelok front ferrule. We've actually deformed it into a bell shape. We've taken the elasticity out of the metal. Not a good thing. You're not going to get a good reseal. So you want to make sure you don't severely over tighten. Another check. You won't be able to check by really looking at the body bevel, because it's just going to look good because everything drives straight in and straight out if you're always supporting the body hex. But what you're really going to notice is on your threads. And a good check, if you think you've over tightened the body, take a brand new Swagelok nut. Take your tube fittings out and your ferrule with the tubing, etc. Try to thread a new nut onto this body. When you over tighten, you have a tendency to expand or swell out the mouth of the fitting. You won't be able to thread on that nut. Quick check, new nut, put it on. If it tightens right up, half turn, full turn, the body's no good, replace it. You've swelled the body out by over tightening the fitting. So just be careful, look for that. You don't want to utilize over tightened fittings. Then, additional safety considerations. Don't bleed the system pressure by loosening the fitting nut or fitting plug. Always depressurize the system before loosening the nut. Don't make up and tighten fittings when the system is pressurized. Pretty much common sense, these. Make sure that the tubing rests firmly on the shoulder of the tube fitting body before tightening the nut. This is extremely important, and again, in the makeup procedure, I feel it's maybe the most important. Make sure that tubing is bottom. If you don't bottom the tubing, what will happen is when you turn the fitting up a turn and a quarter, the ferrules move forward 62 thousandths of an inch. If that tubing is backed off that shoulder 1/8 of an inch, that's 125 thousandths. When you go to pull the fitting up, the ferrules are going to grab the tubing and they're just going to move forward. They're not going to swage the tubing. So extremely important that you bottom that tubing up against the shoulder and then do your proper makeup. Use the correct gap inspection gauge to ensure sufficient tightening after installation. And always use proper thread lubricants and sealants on your tapered pipe threads. Now we have a lot of adapters that make life easy for you. Right here, this is just a tube adapter end. You can take a standard T and you can go to a variety of sizes in male and female pipe, or other sizes if you can't get a reducing T, so you can change things around. Here's an SAE straight thread. You know, you can do a lot of adaptations with adapters. We have lots of different adapters to take you from different sizes. Common issue when you're threading in a pipe elbow with a tube fitting. When you tighten down on a thread pipe, there's really no real specifications on making up threaded fittings. You put on your Teflon tape and you tighten it down till you feel that it's tightened up. But typically, I want to align over here, so I'm tight here. I have two options. I can go around and over tighten, or I can back it off and under tighten and risk a leak. Simple scenario, just go with a tube adapter with a male pipe, put it in, and now you get a tube stub sticking out, and you can attach a Swagelok elbow and get the orientation you want, and easy to maintain by breaking a connection here or breaking a connection there. And again, port connectors. This is the tube adapter end. This particular end, whenever using these, and these are typically used to close couple two Swagelok tube fittings. You can also use a short piece of tubing. That's your choice. But this end, what we do, it's machined from bar stock. So we machine a little groove here that will catch the front ferrule, create the swaging action that we want, and it will hold the burst point of the tubing. But this makeup, when you utilize these ends, is a turn and a quarter. When you use this end, this has the machined front and rear ferrule emulated. So what you want to do is, that is a remake procedure. Effectively, slide your nut over, insert it into the fitting, finger tight, and since you haven't previously made it up, give it a quarter turn snug on the remake. And this is a reducer. We've got a smaller size here and a larger, so you can get these in a variety of different sizes. And again, here's the port connectors. This is showing you how to utilize it. You know, you put the female nut over it, insert it down, and then a quarter turn pass finger tight. And again, for the smaller sizes, 1/8 of a turn. And again, you want to cap off a fitting, use a plug. I call it a cap, but it's a plug. You're going to plug a tube fitting that's unused if you need to. You get a piece of tubing that you want a cap off, utilize a cap. This is a 1 1/4 makeup procedure. We have ferrule packs. If you do a VMI, we have ferrule packs that are straight front and rear ferrules put onto an arbor, or we can give you a nut and ferrule pack that has the nuts and ferrules. I go into some VMIs, I take a look at it, and everybody has a tendency to strip out the ferrules and the nuts off them. So this makes it a little bit easier for you. We talked about soft Tygon tubing. Be very careful with soft Tygon. If you can depress this with your fingers, you should use an insert and sort of insert it right in, push it right in, make sure it bottoms, pull your fitting up, and this plastic tubing will not come out. It will guarantee a safe installation. Depth marking tool. This is important if you're in difficult areas. You may have to kind of snap the tubing into a fitting, etc. You put a depth marking tool into a vise, you bottom the tubing in. It's not depicting it, but there's a machine cutout so you can see that the tubing is against the shoulder. Then you make a mark across the tubing. So now when you install it into a tube fitting and it's in a difficult location, you can make sure that you've got the tubing down to the proper insertion depth. By when you look at the tube nut and it's finger tight, you'll see that line right there, even with the top of the nut. Very important, it can be a very helpful tool. Pre-swaging tools. You make up a lot of fittings in a variety of different sizes. It's a tooled steel. It emulates the Swagelok body. 600 series is 3/8. You put on your nuts and ferrules, insert your tubing. That's showing the front ferrule, rear ferrule nut. You put it on, your finger tight, you pull it up a 1 1/4. You take it apart, your ferrules are swaged onto the tubing. Then all you need to go is to where your installation is, insert the tubing with the ferrule swaged on and the nut, and follow through on your retightening procedure. Very easy tool, helpful tool if needed. Again, we talked about large Swagelok tube fittings. We have the multi-head Swagelok unit, the MHSU. We have a variety of different well heads or multi-swaging heads that go up to 2 inch. And then we have a hydraulic, and then we have some hand. But again, these are for the large fittings. Makes it a lot easier when into those large diameters and very heavy tube walls. Again, our position, effectively, interchange and intermix. If you have 2 inventories of tube fittings, we'll tell you, and I'll tell you, and I believe it wholeheartedly, don't do it. Choose us, choose them, but don't have 2. You know, it's an unsound practice. It can be dangerous. And quite honestly, nobody will stand behind an interchange fitting that you've had a problem, a leak. Maybe you had a serious leak and caused some damage, or you had an injury. Other manufacturers may give you a letter, and the letter ultimately will say that they'll replace the price of the component. To me, that's not good enough. You void our warranty and the responsibility for product performance. Don't interchange. Not a good practice. And then here we have a lifetime limited warranty for our parts. We believe in our components, and they're free from defects, material, and workmanship. It's a limited lifetime warranty. One of the things that we have, this is a brochure that we offer with tube fitting performance product test reports. And we also offer third-party product approvals and registrations. If you're questioning the capability of the fitting, we could send you this. It's over 100 pages, and we have a variety of tests done on the tube fitting. We talked about the big 3. We have a variety of tests that are talked about in tube grip. I'm not going to go through them, but a variety of different types of tests that go into tube grip on various sizes. We get into gas seal, variety of tests on different sizes using different scenarios and fluids on gas seal. Lastly, we go into vibration resistant tests. Again, very important that your tube fitting can hold up under vibration resistance. Then we have tests on alloys. So we have tests on alloys. Not too many people will offer you that. Then third party, summary of third party product approvals and registrations. And then again, I talked about that ASTM F1387 testing of Swagelok tube fittings witnessed and approved by the Department of the Navy. So this is available. We can email it to you or get you a copy. So with that, what I've got coming up is I've just got a slide. And this particular slide is a depiction of the extreme capabilities of Swagelok. It's a short video, but it's an interesting video, and I encourage you to stay on and watch. Here we go.
Many years ago, Swagelok tube fittings were put through a severe thermal shock test at an oil refinery facility in Ohio. The classic film, Ohio thermal shock test, is still a dramatic representation of a rigorous tube fitting test. These film clips illustrate the temperatures, pressures, and stresses our tube fitting connections withstood throughout the complete test with absolutely no leakage. Since this original test was filmed, Swagelok Company has been driven toward continuously improving the Swagelok tube fitting and validating it in a wide range of extreme tests, many of them conducted at third-party facilities. The following will demonstrate some of these tests as they were conducted. A third-party lab conducted a burn test to ASTM F1387 requirements. Testing was performed on 1-inch stainless steel Swagelok tube fittings at 3,000 psig nitrogen pressure. The temperature was rapidly elevated to 1,700 degrees Fahrenheit and held for 30 minutes. As the video illustrates, the fittings and tubing turned a bright red color due to the heat, while maintaining a leak-free connection, as confirmed by a pressure gauge. After 30 minutes, the oven was turned off, and you can still see the fittings glowing as the oven cools. A final gas test was conducted after the assembly had cooled, which the fittings passed with no leakage. Another burn test was conducted on stainless steel Swagelok tube fittings to the requirements listed in the American Petroleum Institute or API 607 specification. Direct flame was pointed toward the fittings from multiple burners for a time period of 30 minutes. The pressure inside the assembly was 2,500 psig water, which turned to steam. After 30 minutes, the assembly was quickly quenched in water. API 607 allows a 5-minute delay between flame shutoff and start of quench. The final proof test after cooling was conducted with 2,500 psig water. The Swagelok tube fittings passed. Another test that was conducted at the Swagelok Company product lab included a combination rotary flex and impulse test. A half-inch Swagelok nail connector was assembled on tubing, then attached to a stationary block. The other end of the tubing was attached to a fitting, which was then attached to a rotary wheel. The wheel has a prescribed angle of deflection and is set to create a specified stress level. The wheel rotation is quickly increased to a speed of 3,500 revolutions per minute. The assembly also impulsed from 0 to 1.5 times working pressure, or almost 5,000 psig, over a 1-second time frame. The overall test is 10 million cycles on the rotary wheel, which takes approximately 3 days to complete, or 500,000 impulse cycles. The Swagelok fitting successfully passed this test with no fitting leakage or tube fracture. Another third-party facility conducted a shock impact test on 1-inch stainless steel Swagelok tube fittings, also to ASTM F1387 requirements. The fittings were assembled and placed in a fixture. A 400-pound weighted hammer was dropped onto the assembly fixture from heights of 1, 3, and 5-foot elevations to simulate the effects of depth charges on submarines. The hammer drop sequence was repeated from multiple angles on the fitting assembly. This video details the amount of impact or side load the Swagelok tube fitting withstood, yet no leakage was detected during the pressure test after the impacts. Due to the application of subsea operations, Swagelok Company designed a unique test rig for the purpose of analyzing external pressure on a fitting assembly. A tube fitting connection is placed into a chamber, and the chamber is filled with water. The chamber is then pressurized so that the assembly experiences external pressure, similar to what an assembly on an offshore oil platform would be subjected to, as it is lowered thousands of feet into the ocean. The external pressure is then increased until the tubing wall collapses under the extreme pressure. No leaks. A tensile pull test is used to demonstrate the effects of unsupported weight on tubing and fitting connections. This test is being conducted on 2-inch stainless steel Swagelok tube fitting at our Swagelok product test lab. The weight load is increased by pulling each end of the tubing at a rate of 1/4 inch per minute. The test is designed to compare the maximum load that the tensile pull reaches before the tubing is forcibly pulled from the fitting. This assembly reached a load of over 45,500 pounds, which is the equivalent of 14,465 psig, well above the American Society of Mechanical Engineers calculated burst pressure of 13,500 psig for 0.188-inch wall thickness tubing. One of the classic Swagelok tube fitting tests is the hydraulic burst test. Shown is a 1 1/4 inch tube assembled to a Swagelok tube fitting. The pressure is applied gradually until the allowable working pressure of the tubing, 3,200 psig, is reached. No leaks. The pressure is then increased in 1,000 psig increments until the tubing yields, and finally burst occurs, demonstrating the integrity of the Swagelok tube fitting. Another modern tool that Swagelok has incorporated into its product test portfolio is finite element analysis, or FEA, which assists our engineers in modeling stresses and loads. FEA is a computerized mathematical technique that depicts the effects of elastic and plastic deformation on materials, such as stainless steel. It allows Swagelok to more comprehensively look inside the fitting integrity, far beyond actual field test application. This pull-up of the Swagelok tube fitting, as it is depicted with FEA modeling, demonstrates the hinging, collating action of the back barrel. FEA was instrumental in Swagelok's development of the advanced back barrel and SAT-12 hardening process, because it allows its engineers to model the effect of any changes before parts are made or sent off for test. This commitment to continuous improvement enables Swagelok to use the most advanced methods for providing exceptional product performance in the most rigorous tests, so customers can continue to receive value beyond the expected.
So I just want to say thank you for attending the webinar. Hopefully you got something out of this. And if you're interested in one of those tube fitters manuals, let us know. On our website, we have live chat. You can just put your information in, send us an email, and we'll get you one. Or if anybody needs a catalog or has any additional questions, please don't hesitate to contact us.